Hello, my name is Ted Bisson. I'm a software engineer at Google, and today we're going to be talking about persistent world-scale AR experiences with ARCore Cloud Anchors and AR Foundation. I'd like to start with a quick overview of what we're going to talk about today. Over the next 45 minutes, we're going to tell you a little bit about how Google's ARCore Cloud Anchor service works. We're going to show you an exciting demo of a upcoming product that's built around persistent AR experiences, and then I'll be back to tell you more about our new offering, ARCore extensions for AR Foundation. To get started, I'd like to welcome to the stage my colleague John, who's going to tell you more about ARCore Cloud Anchors.
Thanks, Ted. Hi, I'm John. I'm going to be talking to you today about ARCore Cloud Anchors. So what are they, and what can you build with them? So first I'm going to talk about building cross-platform shared AR experiences. Then I'm going to dive into some of the details of how this all works. Then I'll talk about some best practices for building good user experiences. Then some recent improvements that we've been making in ARCore. And finally, persistent cloud anchors. So, what can you do with cloud anchors? Well, you can build cross-platform shared AR experiences. So what does that mean? That means that two or more people can be seeing the same virtual content in the same place at the same time. And this works across both iOS and Android. For example, this is a demo called Lightboard that we gave at Google I/O last year. The two players are able to see their two virtual game boards in the same places at the same time using a cloud anchor. They're attempting to shoot little pellets at each other's boards to try to turn them red or blue. There are many other exciting apps out there today that use cloud anchors. For example, you can view the Mars rover together in AR. You can play AR musical chairs together, or you can experience Childish Gambino's universe. Another example is Dino Runner AR. This is an experience that we showed this year at Google I/O. This is a play on the little 2D game that comes up in Google Chrome when you're offline. You want your dino to go as far as it can, as fast as it can. 3 people play at a time with a 4th spectator phone. Now, the AR aspects that you see here in the video were not created in post-production. This is a live recording from the 4th spectator phone. And this was screencast to huge screens at the event for the audience to see. So you can see that cloud anchors can be used to create a really dynamic and engaging game. One of the new games we're excited about that uses the newest version of cloud anchors is Under the Sea. This is an AR dance party where you follow an AR fish around with your friends to create a collaborative dance piece. Okay, so let's talk about how this all works. So first of all, each device has its own AR session with its own understanding of the world and its own world map. Each device will have its own cloud anchor object, generally with distinct coordinates. However, all of these cloud anchor objects refer to the same position and orientation in space. They therefore define a shared reference frame. Each device can then place virtual content relative to its own cloud anchor, and that content will appear to be in the same physical place on each device. So let's go a little deeper. There are 2 basic operations for cloud anchors. There's hosting, where you create a new cloud anchor, and there's resolving, where you add an existing cloud anchor to your scene. To host, you first scan the area around the anchor that you want to host with the device's camera for several seconds. Then you call host cloud anchor, passing the local anchor you want to host. Now in the background, ARCore is going to upload some visual mapping data to the ARCore Cloud Anchor service, which will then process that information. When that's done, ARCore returns a unique Cloud Anchor ID string to the application. That Cloud Anchor ID uniquely identifies that Cloud Anchor. You can share that ID with other devices by any means. To resolve, first look at the place where the Cloud Anchor was hosted. Call resolve Cloud Anchor, passing the Cloud Anchor ID from the previous step. Now ARCore is going to upload some visual data to the ARCore Cloud Anchor service in the background, and the service will attempt to match that data to the data that was uploaded during hosting. In the meantime, ARCore creates a new anchor object and returns it to you. When resolving succeeds, that anchor object will begin tracking with a valid pose. The cloud anchors now define a shared reference frame. By placing the same content relative to the cloud anchor on each device, you create a shared experience. Optionally, you can use a peer-to-peer connection to exchange game state and create a dynamic shared experience. For example, this is a demo that we showed at Google I/O this year. The two devices are able to see the same virtual flower garden in the same place at the same time. And they can even make changes to the garden in real time and have those changes show up on the other device. Okay, so briefly, I'll mention some advantages to doing some of our computation in the cloud. First of all, we can run more powerful algorithms in the cloud than we could on a device. Now that also means we're using less compute and less battery on the device. We can make improvements on the server, potentially without app updates or ARCore updates. And finally, if we do make improvements on the server, they're automatically cross-platform, so they benefit both iOS and Android. Okay, now I want to go over some best practices for building good user experiences with cloud anchors. So first, I'll talk about best practices for AR in general, then for hosting, resolving, and finally, placement of cloud anchors. So first, some best practices for AR in general. So you want to make sure that there is sufficient light in your scene. Now, there's a couple of ways to know programmatically if this is an issue. First, ARCore has lighting estimation APIs that can give you an estimate of how much light there is in your scene. Also, if tracking is failing due to low light, ARCore will return a tracking failure reason enum value to you, indicating that there's low light in the scene. Next, you want to make sure that there's enough visual detail in your environment. Computer vision algorithms work by detecting distinctive visual features in the environment. Oftentimes, these are at places like corners and edges of things. So you want to make sure there's enough features in the environment. And there's a couple of ways to know if this is an issue programmatically. There's a tracking failure reason for insufficient features. There's also an API to get point clouds, so you know roughly how many features ARCore is working with at any given time. Another good signal is being able to detect a plane. So if ARCore can detect planes, that's a good signal that it can see something. Next, we generally recommend that you wait a few seconds after tracking starts in your session before placing AR content. The reason for that is that it gives time for tracking to stabilize. If you don't wait and you place some AR content immediately at the session start, then you may see some strange behavior, such as the anchored or objects drifting around noticeably, or even in rare cases, flying off into the distance. So we recommend waiting a few seconds before placing content. Next, it's very important to move around and see the scene from different perspectives. This is because computer vision algorithms work by triangulating positions in three-dimensional space, and triangulation requires different perspectives. Sufficient movement also helps the system to start tracking stably. On the other hand, you want to make sure the device isn't moving too fast, because excessive motion, particularly excessive rotation, can cause the images from the camera to be blurry, and blurry images are difficult to use for computer vision. There is also a tracking failure reason for excessive motion. Finally, we recommend avoiding reflective surfaces. Reflective surfaces can contain illusory features that sort of trick the algorithms. Okay, so those were best practices for AR in general. Now let's go over some best practices for hosting. First of all, we recommend that you place your anchors near some visual features. For example, on a detected plane. This is not a requirement. If you like, you can place your cloud anchor floating in space. But you should be aware that if the anchor is far away from anything the camera can see, then it may resolve less accurately later on. It's also very important while you're scanning to move around and see the anchor from different perspectives. The more perspectives you cover when you're scanning, the more places you'll be able to resolve from later. And you should cover areas where you want to resolve from. For example, let's say you place an anchor in the middle of a table. If you want to be able to resolve from anywhere around that table, then you should walk around the entire table when you host. If, however, you only need to resolve from one side, then it's okay to just scan from that side. And also, you should call host soon after scanning. This is because ARCore buffers the most recent session data to send to the server. Finally, we recommend avoiding precisely repeating patterns in the environment. This is because resolving works by making visual comparisons between two different areas. So if you've got two different spaces that look identical, then you may resolve in the wrong place, which you could see as both a bug and a feature, depending on your perspective. But we do recommend that you avoid precisely repeating patterns. Okay, so now some best practices for resolving. First of all, look at the anchor from a similar position to where it was hosted from. For example, you could have the hoster and the resolver stand next to each other. Another common technique is to take a snapshot of the area when you're hosting, and then use that photo to guide the user to the correct location when they're resolving. And finally, again, move around to see the anchor from different perspectives. This can help ARCore to resolve the anchor, and it can also help ARCore to improve the anchor's position over time. Okay, so some best practices for placing cloud anchors. First of all, we recommend using a single cloud anchor when your content is within a relatively small area, maybe a few meters, say. However, if you've got multiple pieces of content spread out over a large area, say many meters apart, we recommend using multiple cloud anchors for that. This is because of something called the lever arm effect. So say for a minute, this triangle up here represents an anchor, and this square here represents a piece of content that's placed relative to the anchor. So maybe it's a child of the anchor in your scene graph. And suppose that these two places are very far apart. Then a small rotational error in the anchor will cause a large positional error in the content. So for that reason, it's difficult to precisely align multiple pieces of content to the real world in multiple locations simultaneously if those places are very far apart. Okay, so we've been making a lot of improvements to ARCore, to cloud anchors, since we first launched the feature. And all of these improvements are now in the 1.12 version of ARCore that we launched this month. So for hosting, we've increased the buffer time from 10 seconds to 30 seconds without increasing the amount of data that we use. More buffer time means that you can scan a larger area, which means that you can then resolve from more places later on. It also gives you a little bit more flexibility in the timing of exactly when you call the host method. We've also decreased the latency of hosting. So from the time you call host cloud anchor to the time you get the cloud anchor ID, you should expect that to be about 5 seconds, assuming you have a strong internet connection. For resolving, ARCore now continues to query the server in the background over time in order to improve the anchor's pose. Also, you can now efficiently resolve up to 20 cloud anchors at a time without using any more memory or compute or network bandwidth than you would use for one anchor. This is very useful for cases where you've got many cloud anchors spread out over a large area, and you want to be able to resolve each anchor as it comes into view. We've also been making a lot of accuracy improvements, and this is an ongoing effort, so it's not going to stop with the 1.12 release. And finally, our algorithms are now a lot more robust to lighting changes. In addition to all the improvements that we've launched in ARCore 1.12, we are excited to announce persistent cloud anchors, which will enable a whole new category of experiences, because now you can save AR content at a place and keep coming back to it again and again. For example, you could leave helpful notes for visitors to your house, or you could plan out your interior design project over time. This uses the same simple APIs as cloud anchors for sharing, but you will be able to pass in a lifetime for the anchor when you host it. One of the earliest adopters of persistent cloud anchors is ARCore, a new social app that lets people create, discover, and share their AR art with friends and followers in real-world locations. ARCore is developed by SYBO Games and iDreamSky. I'd like to welcome Jeff Lyndon, ARCore CEO, up to the stage to tell us more about ARCore. Jeff?
Thanks, John, for the intro. My name is Jeff. I'm the CEO of ARCore and also president and co-founder of iDreamSky, one of the largest mobile gaming publishers in China. Over the last 6 months, together with SYBO, creator of Subway Surfer, also one of iDreamSky's long-standing partner, we have created ARCore, one of the world's first real AR social platform. Before I get into how our product is special and unique, I want to give you guys some context on how traditional consumer AR product is like in the market right now. When we're looking into all the consumer AR products or games, we see that most products out there are single-player experience. We most likely draw something and place a 3D object in the room, take picture, and that's it. It is not social at all. And more importantly, what you have done on the AR canvas cannot be saved, which means nobody would know what you have done as soon as your AR sessions ends, even if your friends have your phone right next to you. In ARCore, we want to do this differently. As one of the first AR social platform, our mission is to create a second layer in the world in the AR experience for everyone. And the first step of achieving this mission is to let player and user to create and share AR street art anywhere in the city. Anyone who has the app would be able to experience ARCore through their mobile devices. Sorry. To realize this mission, Google Persistent Cloud Anchoring is a critical part of the equation. Its breakthroughs enable us to different from other traditional AR products. First of all, Persistent Cloud Anchor let our users save AR scenes feature for much longer period, so that AR content that was created and can be retrieved, but in the exact location, even if the AR session have ended. It is essentially the save button for ARCore. Because of that, it unlocks social sharing experience, as user can go through certain location to experience AR scenes. Was created by another user on the platform. In addition, it also let other users to collaborate with one another, just like what you do in most street art situations. Together, that makes AR experience a true social experience. We have created a sneak peek of what we have done, and I'm very excited to show you a video that we have prepared for you tonight. So here we go.
I just do what I do. See me? I just do what I do. Man, I just do what I do. Don't know about you. I just do what I do. Check. That's the intro. privilege for all who can witness this. I am close to divine. Know the moment is mine, need no omen or sign. Oxbridge, providing a back sound to all the squares that ask around. We getting it, my skills pay me. Trying to get a million, baby, with an adopted flow that God gave me. I just do what I do. You see me? I just do what I do. I just do what I do. I don't know about you. I just do what I do. Check.
So now, let me bring my colleague Murari, the creative director of Mark AR and the brainchild behind it. He will tell you more detail on how exactly we used it, Google Cloud Anchor in Mark AR. Thank you.
Yeah, thanks, Jeff. And hello, everyone who's managed to make it out to Unite on this bleak, gray day in Copenhagen. I'd love to tell you that it gets better than this, but honestly, it doesn't. And if I said it would, I would be lying. We're based in Copenhagen as part of SYBO Games, and we are the creators of Subway Surfers. And we love the fact that Unite has actually come back to Copenhagen this year, coming home in a way. We were also heavily influenced by the street art that's prevalent in Copenhagen. So if you do get a chance to go and explore neighborhoods like Nørrebro, you'll find lots of great examples of street art there, and part of the inspiration for this app. So as Jeff mentioned, I'd like to talk a little bit about how we made Mark AR happen inside Unity using ARCore. And I'd also like to talk a little bit about some of the design and tech choices that we had to make along the way, which I'm hoping some of you in the crowd will be able to take away for use on your own projects. So let me just get started. To set the stage, I know most of you won't be able to read the text here, but I'll try and run it through with the icons. This is the basic flow of the app. So there's two things that we actually just want to do with this. We want to create and we want to discover. And this harkens back to what John was mentioning towards hosting and resolving. So to create, we want to scan the real-world environment, and we want to identify surfaces on which we can create an art on. Currently, there's horizontal and vertical surfaces, but we hope in the future there will be many more. We then select the surface that we want to start creating our masterpiece on, and at that point, we sort of host the cloud anchor and send it to our servers. We then proceed to let the user create their masterpiece by moving their phone around in a very intuitive manner. And then once they're happy with it, they can publish it to both our feed as well as our map view, using it from the same database. To discover art by your friends and followers, you have the feed view and the map view, and you select the entry that you want to look at in the real world. And then we then, at that point, check how far are you from this beautiful work. And if you're within walking distance, we give you walking directions to get there. If you're not, then you'll be able to interact with it in other offline ways. But if you're very close, within GPS range, at which point directions don't make much more sense, we take you to the AR view, where you can actually relocalize and resolve the piece in the real world. And we do that by querying the Cloud Anchor, using Cloud Anchor ID. And then as the user moves their phone around, the art appears in place as if by magic. So this is the basic creation flow. It consists of two things. You scan the environment, and then you tap it. So scanning does two things. As you can see in the GIF, it helps you identify, in this case, a vertical plane and other AR surfaces. But we also decided to repurpose it to follow the guidelines that John just spoke about. So behind the scenes, when you host a Cloud Anchor, ARCore actually sends 30 seconds worth of visual feature data for helping relocalize content. So we get the user to move their phone around with some UX help, and that helps them also scan the environment, which helps us relocalize for other users. And once they're happy with their surface, they tap it, and tapping basically we know that they want to start spraying really quickly. So we create an art canvas, a virtual art canvas at that point. And we then host the Cloud Anchor. So it's a good indication for us that they're happy with the host and sort of they've set the stage. Now when you want to discover art by either your friends or followers, we have two entry points, as I mentioned. You can see them in the GIFs there. So you have the map view and the feed view, and they curate content differently. So the map view as you would imagine, curates content and shows you relevant sprays and other pieces in the location around you. So if there's something really nearby that we think you should see or that provokes your interest, we would show you that over others. The feed view has we're toying with a few different curation models, one of which you could see possibly work by your friends, which might matter to you much more than, say, random person X. You could also have a trending view where you could see the top pieces that have been created by people. And finally, you could see stuff that's close to you and what's hot. So this way, we have a couple of different entry points into the same system. But regardless of which method you use to find something that you're interested in, that you actually want to walk to in the real world, we then check how far you are from it, and then we take you through a different flow. So if you're a bit further out, you have to walk there, and we want to encourage you to walk and explore neighborhoods as well. So this is less a static experience and more actually in the real world, which is what really excites us about this app. Because as Jeff mentioned, most AR apps are generally sort of room scale, and they're static experiences shared by very few people. So this is truly world scale. When you're in the AR view, how do you know where to look? We've tried a few different design solutions to guide users in the right direction. One thing that John mentioned was taking a little snapshot, and we call this the milk carton approach. And as you can see in this little GIF, what we do is we offer up a little thumbnail of where the art was made as a sort of hint to where the resolving user should look. Now, this GIF's actually not 100% correct because we don't want to actually show the virtual content, but we just want to show the layer where it was made and sort of maintain that surprise and mystery element. We feel this is kind of provoking the treasure hunt feel, which we like. And this, we found, works quite well if the surface that it was made on is quite visually distinct. As in this example, you see it's a fairly distinct featured surface. But when there are situations where this art has been made on surfaces that are quite generic or that are sort of repeating, which we know we shouldn't do, but sometimes they might be, we find that users then don't know exactly where to look. So what we're trying now is to get the user who creates the art to also do a little short video capture of the area that they made it, so that the person who's discovering it knows precisely where to look, but still keeping that sort of mystery treasure hunt feel, which we think is really cool. In the future, we want to try and localize from larger areas and perhaps guide users from within AR itself. If you imagine sort of a game HUD, you can kind of see direction pointers, and we can get users to walk around in AR and hopefully discover content precisely. This is something we're waiting for. So, coming now to actually virtual spray painting in 3D using Unity, how do you actually spray paint virtually? As with Unity, there's the asset store, which is a treasure trove of handy things you can just plug into your project. We found this package called Paintcraft Pro that is by and large used for coloring book apps and lets you paint on 3D objects in 3D space. We found this to be a good starting point, and we had to modify it a little bit. So we had to use the camera as the raycast source for one, which worked really well, actually. We just childed the camera, and then you get, whenever the user moves their phone around, it acts as the paintbrush. This is very intuitive and keeps the sort of spray painting fantasy alive, which we think is a good design solution. And then finally, we also added some noise and some diffusion to the brush stroke, so it feels more like genuine spray painting instead of just sort of cartoony art. And finally, we also extended the pipeline so that we can create spray caps, which are our sort of terminology for different brushes, which lets the user spray differently. So imagine being able to spray paint the world in pixels as opposed to little noisy spray brushes. So this is a wealth of possibility here for creation and sort of creativity tools, which we hope to be able to explore both with our own developers as well as the users and you guys. So when it comes to rendering, this is something that we really focused on a lot. How do we get this virtual content to look like it's been made in the real world? I mean, a lot of AR experiences, you find 3D content that's just sort of sitting there on your table, and it really doesn't look like it belongs. Whereas here, we wanted to get the actual spray to blend in with the background underneath. So we explored a few, and we're just starting to sort of uncover what that means and where we can improve this. But some of the stuff that we've found works really well here is using a blend mode. what you're seeing here is the fact that this is an overlay blend, which is a combination of both multiply and screen blend. And this is something, for those of you who are familiar with Photoshop and screen shaders, that this is basically heightens or brightens the bright areas and darkens the dark areas. So here you can see that we wanted the textural detail of the brick coming through, even though we're actually just spraying virtual pixels on it. And we think this is a good start. And finally, one of the key lessons that we learned by working on this project is that creating content in AR is hard. And even if we give users complete flexibility to do what they want, it's hard for people to create stuff that looks good. So what we wanted to do is give them the same creative freedom, but allowing them to make stuff that we generally know is easier on the eyes. So we came up with a very natural concept of stencils in AR, which work exactly the way real-world stencils do, in that you hold a stencil over a canvas, you spray on it, and then you lift the stencil to reveal what's underneath. We found this very intuitive, and we kept the process and the interaction fun. So while there's still people are still able to express themselves, we know that it's going to look good. And then following on from this concept, we also came up with multi-layered stencils, which means that you can allow people to create something that's a little bit more complex, and also giving users the ability to personalize their content. So the ability to create stencils from pictures, from selfies, from text as well. So if you wanted to, let's say, invite your friend for a quick beer after work, and you wanted to have a little secret about it, or some friend that you haven't met in ages, you can just type a text message, and that becomes a stencil. So instead of having to hand scribble your message all over the wall, this makes it quite easy and casual in a way. So we think this allows people to create personal art, which I think in AR is something that we need to focus on a bit more. There's a whole bunch of things coming up, to summarize, there's a whole bunch of things coming up that we're really excited about and that we want you to keep an eye out for. One of the things is being able to paint on things that are not just vertical and horizontal surfaces, but possibly a more rich palette. Other things are creation tooling, so maybe allowing the user to create lettering that expresses their own personal styles, like signatures. Each graffiti artist, each street artist also has their own style in even text. We also wanted the user to be able to create effects, animations, 3D. We think all of this in a way where it fits with the street art fantasy. We think it could be really powerful. And finally, we also want to explore offline creation. So not every time are you going to be able to stand in front of a thing, a place, and be able to create a masterpiece. Your phone might get hot, but also it's a little bit of a socially awkward situation as well. So we want the user to be able to save a surface and create a piece and work on it and collaborate with their friends offline. We think this could be very exciting to explore. So that's it. I'd like to now invite Ted Bisson from Google. He's going to talk about ARCore in AR foundations.
Thank you, Murari. That was really cool, wasn't it? I only got caught tagging once as a kid, but I can't wait to get a hold of this and mark up everything in my neighborhood. Like many new technologies, persistent AR content can be a really difficult problem to solve. And that's why we at Google are looking to you, the developer community, to help us make sure our solutions are the best they possibly could be. If you're interested in talking with us about persistent AR content, please consider visiting the link here and signing up. I'm going to show this and the other links again at the end of the presentation. But moving on, again, my name is Ted. I work on ARCore's integrations for Unity at Google. Today, I'd like to talk to you a little bit about our new package, ARCore Extensions for Unity's AR Foundation. Before I get there, over the next few minutes, I'm going to talk briefly about our current standalone SDK and a little bit about how AR Foundation is put together. Then, to be sure that we're all on the same page, I'm going to do a very quick overview of C# extensions. This is the basis on which we're extending AR Foundation. Then, we'll talk a little bit about how to put ARCore extensions into your project, and then dive off into the code, and I'll actually show you how it works. All right. ARCore SDK for Unity is our current SDK that allows you developers to add ARCore technologies to your Unity apps. It's been out for well over a year now. It's established and supported online. There's a vibrant community of developers and apps currently using it. You can find more information about this and all of our ARCore technologies at developers.google.com/AR. But Google wasn't alone, obviously, in making ARCore technology. And so Unity decided to create their cross-platform API surface called AR Foundation. It's distributed as a package through Unity's package manager, and it gives you access to all of the basic AR functionality that you'd want to use in your apps. Unity built a middle layer to interface with all of the lower-level technologies, such as ARCore. Then they implemented those middle layers to provide those services directly to AR Foundation. You can see here that the ARCore XR plugin from Unity directly accesses ARCore on your device to provide those services. ARCore Extensions lives up here. It will extend AR Foundation, add new features directly from ARCore that may not yet be available through AR Foundation directly. Now, let's talk momentarily about how this works. C# extensions. For those of you who do not know, this is a language feature in C# that allows you to add methods to existing classes that you don't otherwise have access to, for example, a sealed class. Once you've added those methods, you can use them, just like any other method on that class. Now, most of you are developers, and you probably want to see this quickly in code. So let's do a quick example. What we're going to do here is we're going to extend the existing string class. To do that, you create a public static class. In this case, I'm going to call it string extensions to keep it organized. Then, define the function that you'd like to add to this class. Note the important part here is that the first parameter to your method is a reference to the object it's operating on. You can add more parameters, but I'm not going to do that for this particular example. Then, implement your function however you'd like to do it. In this case, I'm not going to show you how it's done. I know some of you might use this as an interview question, and I don't want to spoil it for everybody. Once you've got that in place, define your string, and then just like any other method that's already on that class, call it with the traditional syntax, mystring.reverse. It'll call your function, and it will return the result. This is how we're doing it for AR Foundation. Now, back to Cloud Anchors. The driving force behind AR Cloud Anchors is to create an environment for people to come together and do interesting things in augmented reality. Two people can stand next to each other playing the same mobile game, and that's interesting. They can talk about it. Add multiplayer, and that becomes a whole new experience and opens up many new opportunities. Now you're playing the same game together. Did I skip? Sorry. No, here we go. Now, through our cameras, augmented reality allows our devices to see the world around us. And through Cloud Anchors, we're now able to share those same world views across multiple players. Let's start putting this together. You probably want to know how to add ARCore extensions to your project. Couple of requirements. You're going to need to use Unity 2019-2 or later, and you're going to need to access Google's GitHub repository for the ARCore Unity extensions. Now, here's what it's going to look like in your editor. As you can see, a default project created in Unity has a bunch of packages installed by default. To get to it, just click on this little plus button up there, and then click on Add Packages from Disk. Then navigate to wherever it is that you downloaded a copy of the ARCore extensions repository, and point at the package.json file. That's it. The package manager will download it, will install all the relevant dependent packages, and you'll be ready to go. Now, keep in mind, in future versions of Unity, 2019.3 and forward in particular, you can actually use the GitHub link directly, so you don't have to make a copy of the project locally. Now, there are a couple things you're going to need to add to your scene to make this work. First, you're going to need a game object. This will give ARCore extensions an opportunity to interface with your environment better. You'll need a configuration to tell ARCore extensions which of the features you want to use and how you want them set up. And then you'll need to add a few references to existing AR Foundation objects, and I'll explain about that in just a moment. So, you'll find the ARCore extensions game object in the game object menu under XR, right next to all of the other AR Foundation features. You can create the extensions configuration as an asset from the assets menu under ARCore extensions config. Once you've created the configuration, you can specify exactly how you want to use ARCore extensions. In this case, our first release, you'll have access to Cloud Anchors. Then, hook up a couple of references to the existing AR Foundation objects you want to use. While it's not recommended, it is possible to create multiple AR sessions or AR session origins in your scene. This can cause some problems, but there are some valid use cases. In order to prevent any confusion with how ARCore extensions works, we're asking you to use this interface to tell us exactly which ones you want to use and when. Now, before we talk about the code itself, let's talk about naming for just a moment. Here we have AR Foundation, the new API from Unity, and we have ARCore SDK, the existing SDK that Google's got out there. AR Foundation refers to a point in space that's tracked, that stays focused as you move the device around, as a reference point. ARCore uses the term anchor. In fact, AR Foundation's reference point is backed by an ARCore anchor if you're using an Android device. So when we came to add cloud references and cloud anchors to the system, we decided to call it Cloud Reference Point to be consistent with AR Foundation's terminology. This is exactly equivalent to an ARCore cloud anchor. And similarly, we have a Cloud Reference ID versus a Cloud Anchor ID. This is just a string representation that you use when you communicate with the ARCore Cloud Anchor service to distinguish which anchor it is you'd like to resolve. All right, so let's talk about how you add a cloud reference point. It's pretty easy. First, you need to create a local reference point. You'll create a cloud reference point from that, and then you just wait a little bit until it becomes ready to use. So, into the code. Here we are, using some standard AR Foundation code at this point to add a reference point. You'll need a pose. A pose is just a position and rotation in space. Typically, you'd get one of these by letting the user tap on the screen, raycast into the scene, and find a point of intersection. Once you've created your local reference point, you can use that to create a cloud reference point. As long as you get something back at this point, you're ready to continue. There are a couple of cases, so for example, you haven't fully configured your system, that might fail to create a point here. Now, in your update loop, you need to poll the state on that new cloud reference point to see where it stands. When it reaches state success, it's done and ready to use. Here I'm taking some random game object in my scene, and I'm setting the parent to the cloud reference point. This will now allow me to track that game object as if it were positioned relative directly to the cloud reference point. Now, it can take up to 30 seconds or so to resolve or host a point through the system as communication goes to the server and back, depending on your network connection. Typically, we expect this to happen a lot faster, on the order of like 5 seconds. So you're going to spend a little bit of time in this task in progress state while you're waiting. Once that's done, otherwise, you may encounter a state that represents an error, and that'll be very clear. For example, you weren't able to connect to the internet. Now, resolving a cloud reference point is fairly straightforward as well. You're going to need to start with a reference point ID that you can get from the device or client that has hosted the point in the first place. You'll use that to resolve the point on your machine, and then just as we did before, you'll wait for it to be ready. So back to the code, starting with that reference ID that you obtained from some other client, add that in as the parameter to resolve cloud reference ID, and then you'll get a point back. I'm going to take just half a second to point out here that this is the reference point manager, and we're using C# extensions to define these new methods that don't otherwise exist. That's why it looks like it's just a natural part of the reference point manager. Okay, so you've got your resolved point, and now you just wait, just as we did before, until it hits state success and you're ready to go. Now, it's important to reiterate that at this moment, you now have 2 points on 2 different clients, or more, and they represent not the same coordinate system, but the same reference point in space. Each device has its own world space. It'll be up to you and your apps to decide how you want to communicate that information from one device to the other. Let's talk about that for just a second. Networking is another hard problem, but that's outside the scope of this talk. It's important to know that your apps need to tell each other what you're doing relative to these reference points, cloud reference points that you've created. So one client creates an object, binds it to the reference point, and then it sends information to the other clients in the system and tells them, I created this thing at this relative position to this particular anchor. Now all of them can share the experience, and you can build new and fun games and experiences for everybody. Networking systems can be tricky. We at Google have been using Unity's built-in multiplayer service to help host rooms, find other players, and to do some of that communication. It'll be up to you to decide what works best for your situation, but we do encourage you to be very careful when you design it, as it can be a pretty tricky problem. Now, that pretty much wraps up what we've got here today. Tomorrow, I'll be hosting a code lab here, where participants will be guided through the process of creating a simple Cloud Anchor-based app using ARCore extensions. Currently, in this first release, ARCore Extensions works for Android. In our next release, we will support iOS as well. Here again are all of the links to what we discussed today. If you'd like to participate in the conversation about persistent cloud anchors, please visit this and sign up. For more information about Google's AR offerings in general, developers.google.com/AR. And here's a link to our GitHub repository for ARCore extensions. So with that, on behalf of John, Jeff, Murari, and myself, I'd like to thank you all for joining us today. And from all of us at Google, we can't wait to see what you build next. Thank you.